Welcome to week 3 again. We were planning on doing this next week. I decided to just do 2 weeks in 1 week because it'll give you guys more time to do the assignment. But also, these are a lot of these topics we can cover asynchronously. I have a lot of lectures on visualizations already on YouTube, and y'all can ask me questions. And this is not the primary focus of the class. I'm just going to give you some basic visualization design ideas today. You're going to see some examples of running visualizations in Python, which you've already seen, but we're going to do a little bit more work today. And then we're going to see what we need to do next week. If you have questions, we're going to run another lab with visualizations as needed. Okay. So next week might be another sort of visualization lab. Okay. And another reason is that this way, all of our labs the topics will be after the lecture has been done. Okay. So this is from my course. So a lot of you might have seen this, but first, before we get into what's visualization in the context of data science, I want to just give you some best practices. So let me just first get some ideas in how we think about visualizations if you haven't thought about it, right? So we have a data set. The data set, if you remember, is a table with rows, for example, and then with columns and then rows, right? So each of these is an item. I've already shown this to you. And each of these is a variable, and each of these is a value, right? So let's say you want to visualize this. This is assume that this is height, right? You all know that we all have quantitative, qualitative, like categorical types of data, right? So if you don't, go back and look at these types of information. In this course, we've covered it, but there's lectures in my visualization class as well, right? So let's say we have a height that we want to visualize, right? The general idea of a visualization, very quickly, is to take these numbers and then map it to some shape, encode it somehow, right? With some graphical mark, right? So essentially, if we want to use circles to show height, then we say the mark is circle, and then you want to encode the height into size, then you will have something like this. People who are taller will have larger circles. Okay? So we have encoding and we have marks. You can choose different marks. You can use, for example, you can set, let's say, weight. Let's say you want to visualize weight as well in the data set. Okay? And then you can say, okay, I'm gonna map weight to color. And then you're gonna do, for example, like a light red for light people, and then heavier, you do this, and then I just want to give you the intuition, right? The heaviest you do this, right? So you can do something. So these are the very first ideas. So you take data, you visualize it, and you map it to, like, you encode it somehow with some graphical property. Now because we're doing weight and height, this is a bivariate visualization. We're visualizing both height using one channel and visualizing weight using another channel. Okay, in terms of the language of how we think about visualizations. Okay, but now today, that's all good. You can go watch videos. You probably have taken a class. This book from tomorrow, I teach it. It's a good book. If you're interested, I can introduce you a lot of different books. But there are some rules of thumb. We're going to use Python. We're going to use libraries, ready-to-made visualizations. A lot of these visualizations are like histograms, are easy to make, but there are guidelines that I want you to follow. These are basic ideas of visualizations. No unjustified 3D, no unjustified 2D, eyes beat memory, resolution over immersion, overview first, zoom and filter details on demand, responsiveness is required, get it right in black and white. Function first, form next, okay? So these are some even with the text, you probably can guess what the ideas are. Okay. No unjustified 3D. If you should not, basically the idea is that in the older days, people used to do these types of weird 3D pie charts and PowerPoint. Do not do that. There's no reason to create a 3D visualization. It's not impressive. It's not cool. It's not funny. Okay. Unless you want to make it funny or make fun of some people. Otherwise, if your goal is to be cringe or something, then that's good. So no 3D. In general, when people want to see something in space, right? We don't really perceive the 3D space. We perceive sort of a projection of the space in 2.5D, right? And you might also have seen these pictures where, in general, our ideas of depth can be broken super easily, right? So when you do this, and then when you create a weird, ugly visualization like this, you might occlude information. Occlusion happens, right? So there are various ideas. So why not just do this? Instead of doing this, create like 4 bar charts close to each other. That's so nice and easy to read, right? So another reason why not 3D is basically because encodings or channels like length you don't know where to read it. It's going to create inaccuracies. And these 2 green and blue ones probably have the same value, but because it's in perspective, you're going to see your brain is going to read different values. Okay. If I ask you to find the least pi here, pie charts are bad at allowing you to compare, but in this case, it's just awful to do, right? You can see that even though this looks larger, item C looks larger or at least equal to item A, it's much smaller if you do it in 3D. So perspective 3D is bad, but you could do 3D sometimes when it matters, when you have some sort of ideas, you can create these 3D interesting time series. Although there are better ways to do it, you can break it down into multiple views and allow people to select and highlight it in another view. You are now all data scientists, so you can create these different visualizations, right? But if your data is 3D, if you're visualizing an architecture or building or 3D or the earth, that's okay. If you want to visualize wind flow in a building, then that's 3D information, go for it. It might matter, right? So, but for abstract data, most data types that we deal with, it's really unjustified. Sometimes over visualization, even 2D is bad, right? So this is weird. If you make this, like, why are you making this meme of a visualization, right? Sometimes people, if you want to make a network visualization, if you want to read the text, if the network information is not the reason for you to see it, then you shouldn't do it, right? You should think about simplicity. Don't give people too much information, right? Do you need to make a crazy network visualization? How else can you do it? Maybe just a ranking visualization is enough, right? Sometimes the slope helps you find out how much ranks have dropped over a few years. So you might then actually do this, right? This is a good visualization because you can track South Carolina and see how changes have happened, right? So it's your choice. But again, sometimes 2D is helpful. High-speed memory. Lost the... I had the link. Let me find it again. A lot of you have seen this. Okay. So look at this.
This is a test of selective attention.
That sound? Share settings. Okay. I'm going to stop sharing. I'm going to share again. Share sound. Sure. And then Google Chrome. And then... Okay. How about now?
This is a test.
Can you hear me? Okay, we have sound. Perfect.
Of selective attention. Count how many times the players wearing white pass the basketball. How many passes did you count? The correct answer is 15 passes. But did you see the gorilla? This video is from research by Daniel Simons and Chris.
So I've shown this before, but how many of you actually saw the gorilla? Turns out that a lot of people don't miss that information totally. Yes, people here might have seen it. Yeah, people have seen this video. But yeah, it's the first time you won't see it. So essentially, when we are focusing on something, we might, our brains is gonna not detect other thing, right? So that's why when you ask people to rely on their memories or their brains, is gonna give them trouble, essentially. It's called cognitive overload or something. So you want to use something like external cognition. You want to help them think. How do we do that? So you externalize it for them. You write it down, you visualize it, right? You're uploading cognition, thinking to perception, to seeing, right? So because it's easier to visually compare things side by side than to compare something to memory, right? So you don't want to show people something, ask them to remember, and then show them something else. Oh, do you remember that you've made a choice or you've done something like that? Okay. So instead, you show things. If you want to show temporal stuff, you show them, right? You can show people where people have passed. In visualization, the same thing happens, right? So remember, focus on bringing things. Again, this is very abstract information because you have to practice it. Focus on that. This is just an overview of best practices. You all can do a lot of interactive stuff, right? You can first show the overview of the information to people, something like this. Then you can allow them to zoom and filter, right? But still show them the overview. And then you can also allow them to see the detail, right? So zoom, overview, and then selection. This is like a flow that works with interactive visualizations. And there are a lot of examples that you can think. So at some point, I'm going to teach you a little bit of how to do something with Streamlit to make interactive systems with Python. And then you will see how to do that, but think about it and imagine how you might do this, okay? I'm going to skip this part, but your visualizations need to be responsive. Different people look at things in different scales, in different monitors, different views, so you need to make it accessible to people. And this accessibility is not only about the responsiveness, right? First of all, when you do it, you want to give people visual feedback when they do something, when they see something, right? Because when something really quick happen, you can use that for mouse over highlighting, right? So if I come here, you can highlight it for them. That's perceptual processing. You can give people 1 second immediate response, fast responses after mouse click, for example. People see that, right? So after a click or button press for 1 second, people can conceive that. And for small tasks, you can up to 10 seconds, people can get that. This is a visual feedback for something they've done. So make things scalable, highlight selection without complete redraw of the view, show hourglass for multi-second operations when there's a lot of data, show progress bars for long operations. Again, these are when you have large data set, rendering speed when item count is large. You need to show people how things are coming. You can dynamically query something, help them see some parts of the data using a visualization. There's a lot of examples of that. And we get to now some more design ideas, right? You don't want to start with aesthetics for visualization, especially for data science, because the goal here is to communicate and to understand and see. Because it's difficult to add function retroactively. This is a famous example. If you build this pod, it's called a masochist teapot. You ain't going to be able to use this, okay? You want to use basic graphic design ideas, group related items together, avoid equal white space between unrelated items, use alignment, avoid automatic centering. A lot of people just automatically center stuff align things, unify by pushing existing consistencies, so you use repetitions, and use contrast. So if things are not identical, change change something. And these are something that a lot of you have seen. For people who are new to this class, again, I can guide you to other resources for this. Labeling is really important. Meaningful and useful titles, labels, and legends. You want to make them readable. Access and panes. Sub windows should have labels. Access should have good min max. Boundary tick marks. Everything that's plotted should have a legend. Use reasonable numerical formats. Okay. So all of this. So labels like this. So two people in a relationship say, I think we should give it another shot. We should break up and I can prove it. Then there's a visualization of our relationship. Maybe you're right. I know data would convince you. No, I just think I can do better than someone who doesn't label her axis. So that's a meme about like, this visualization is bad. This is a nerdy visualization type of joke. Okay? All right, color. You want to make it right in black and white. So let's look at this. See, this is a good visualization. You can see everything, read everything here. So there are a lot of different color scales that you can choose. And these color scales each have different ways, different uses, right? For example, this viridis color scale emphasizes colors that are perceptually uniform, meaning that values close to each other have similar appearing colors, and values far away from each other have more different appearing colors, right? And this is robust to color blindness. So the properties that you want to show that are common are robust to color blindness. Okay. So see, you can, and some of these scales, and you can look for these names in Python and you can use these scales, right? However, see how viridis was gradually changed and then you were able to see the colors? Look at rainbow color, never use it. We hate it. See, here and here is basically the same. It's the same. You don't want to use that. Compare that to magma and viridis. Okay, so remember, do not use rainbow colors. See how these are different perceptually uniform color maps help. Okay, you have readings to read on this from the book. One of them is Edward Tufte, one of the people whose thoughts on visualizations have been influential. He also has some guidelines. His idea is that you want to show the greatest number of ideas in the shortest time with the least ink and smallest space. Some places this is good. This is a good idea. So two main truths: tell the truth, graphical integrity, and do it effectively with clarity and precision. So the design principles are graphical integrity, maximize data ink ratio, avoid chart junk, micro readings and small multiples, and minimize unite grids, labeling legends. Appropriate applications of color. We've already seen color. This is all about things that we just discussed, but let's look at data ink ratio. Basically, data ink ratio is the proportion of the graphics ink devoted to non-redundant display of information. So you want to basically maximize this. You want to make this number large, right? And we can look at some examples of it later. Chart junk, I love these visualizations, but in a data scientist world, not in a communications world, this is too much information. This is chart junk. These are not related to communicating the information. So generally, you don't want to make a Jupyter notebook with this visualization in it. Generally, you just want to have a simple bar chart. Okay. I cut on some information. You can go to the other visualizations because, again, I don't want to focus too much on this. But here's some general rules of thumb. Some visualization encodings are harder to and noisier. Remember, these are basically some core ideas of visualization psychology. Some illusions distort data. Global statistics are fast. Comparisons are slow. So guide viewers to the right comparisons. First, I told you about visual encodings. Position, so basically putting something on the x-axis, bar chart, for example, and length. These are it's more accurate to read than angle and color. So differences between these are harder to understand. They are noisier. It's noisier for people to read these values. You want people to be able to read these values. So these are better. Okay? So if I show you this visualization, you will think, oh, One Piece is way more popular. And which kind of is, right? However, this visualization has an illusion. It's misleading. It's not starting from zero. So if you actually show the correct data, the difference is gonna feel much less drastic. Even though One Piece is more popular, it's not that much more popular. So you should be careful when you truncate an axis, okay? So some illusions distort data is about this. Use caution with non-zero axis because people read it differently. Stacked bars. A lot of you will use stacked bar charts. Look, people can read the first stack, but the second one, because the bases are different, it's harder for people to compare the differences. Sometimes differences is larger for lighter segments, right? And intensity over intensity is a bad idea. These two are the same color, right? But are seen differently. So go back to these when you want to look at this. Another idea of a distortion, almost never use a dual axis. This visualization is looking like products 1 and 2 are moving together. However, the reality is they are not really moving together. In some cases, product 1 there's much more fluctuating, right? So avoid dual axis chart. This is from a Alberto Cairo book. So global patterns. People are so fast at reading averages. If I tell you to find the average point of all the stuff, you can easily visually guess it. So that's the average number of episodes around here. Average viewership is around here. Okay? So global statistics are fast, but comparisons are slow. So find the anime with viewer lower in 2025 than 2024 and type it down. Correct. What did you have to do? Exactly. You really have to pause to look, right? So the thing that you have to do is you have to one by one do the comparison. You have to go, oh, One Piece. Is it correct? No. Is it correct? No. Oh, this is correct. Oh, no. No. Correct. So you have to do a visual search. This is a slow process. This is a comparison. That's slow. What can you do? Highlight things that you want to show people. I reiterate, highlighting is such a simple and powerful strategy. Now you know which ones are shown. You're a designer. You can tell people what they need. You can do even more. Just give them the story. Attack on Titan and My Hero Academia have reduced viewerships. Boom. This is a better visualization because it just does the job. Okay? Highlight, annotate. These are the ideas, right? So guide viewers to the right comparison. You can even calculate the differences, right? If you had calculated the differences between 2025 and 2024, then the visualization would look like this. And then it would just be much faster to read, okay? So there's this paper, The Science of Visual Data Communication, What Works. It's about 40 pages. It's a long paper, but it's a really good paper for anyone who's interested. It explains all of this information that I just gave. Okay, lastly, when you design visualizations, think about these 3 verbs: simplify, structure, story. Simplify is about getting rid of the information that you know people are not going to be able to read, right? Structure, align things, make sure that you know where things are going, and then do some storytelling, okay? So, for example, let's transform this chart. This is a data scientist dream, right? You have a Jupyter notebook, you've got a bunch of text, and you just give people this chart with a legend. You can do so much better. Get rid of the text. First of all, when you look at this legend, what do we have to do? You have to look at this, okay? Your eyes have to come here and find this. And then you have to remember this is 55. Eyes beat memory. So another one, you have to do a comparison. You're doing search, right? Why should you do that? You have to remember all of these colors. A lot of you don't use legends unless you have to. So get rid of the legend and directly annotate the chart. Now it's immediate because they're structured and they're in the correct space. Your eyes can see which line is which super quickly. Even more, annotate the charts to tell a story, right? You want to say this one increased, draw a line and say what has happened instead of having a text and then showing the visualizations. Again, eyes beat memory. So you have a text, people have to remember what is they've written and see the visualization. Instead, directly visualize it for them. Even more, highlight an element on the chart. Okay? You want to show that this is an important thing you want to highlight, do that. Highlight that specific one. Okay. That's the crash course. Basically, some of the things I think, instead of a whole course in visualization, the basic visualization design ideas that you want to take, right? We've already shown you histograms. We've already shown you sort of box plots. So let's take maybe 5 minutes. And you know what? We're going to do a little bit of visualization next week on Monday, right? So remember this, watch the video. I want Mehdi to continue last week's, like yesterday's coding and record for you. And then I'll teach you some basic visualizations based on these charts in a little bit of time on next Monday. Okay? And let's not, Mehdi, like how much time do you think it'll take you?
It's not gonna, it's around like 15 minutes, 15 to 20 minutes.
Perfect. Okay.
Yeah.
So I'm going to stop sharing. I'm going to stop recording. And thank you all. This was the visualization. Again, so for some of you who haven't taken a visualization course with us, email me. I can share resources. And slowly we're going to learn together. I'm going to help you make good visualizations for your data science work. However, for the rest of you, I know that a lot of you have taken this class. So I don't want to reiterate, but this is a core idea.